Hello everyone, and in this video I will be talking what is Kubernetes and why we are using Kubernetes. So introduction to Kubernetes. Kubernetes is a portable, extensible, open source platform used for managing containerized workloads and services, emphasizing both declarative configuration and automation. Kubernetes boasts a large and rapidly growing ecosystem. Its services, support and tools are extensively available due to its open source nature. And Kubernetes used for managing containerized workloads and service. It emphasizes declarative configuration, emphasizes automation, is portable, extensible and open source. Origin and development of Kubernetes. So the term Kubernetes stems from Greek translating to helmsman or a pilot. The abbreviation K8S comes from counting the 8 characters between K and S. So in some places we use K8S because there are 8 letters in between K and S. And Google played a pivotal role in developing Kubernetes and open sourcing the project in 2014. It combines Google's over 15 years of experience managing production workloads at scale with community's best practices. Deployment evolution from traditional to virtualized era. So initially organizations ran applications on physical servers with no resource boundaries, leading to resource allocation issues. One application could monopolize resources, causing others to underperform. Running each application on a different server was non-scalable solution with underutilized resources. Virtualization was introduced to solve these problems, allowing multiple VMs to run on a single physical server's CPU. It improved resource utilization and scalability, reduced hardware cost, and allowed applications to be isolated for security purpose. So initially like long back, like organizations used to run physical servers and application used to run on physical servers, and those applications which uses resources and it caused issues, something like monopolize. It will consume all the resources on the physical machine, and some application may underperform. So they have tried separate server solution, which actually in sometimes leads to underutilized resources, because if you have for every application, if you dedicate a physical server, then it may so they have a problem of either overutilization or underutilization with the physical servers. Then organizations started using virtual machines. So this was before virtual machines, when applications ran directly on physical servers, which actually improved resource utilization, scalability and reduced hardware costs, allows as isolation for security purpose. But then deployment evolution came the container era. Containers, similar to virtual machines but with relaxed isolation to share the OS operating system, emerged as a large lightweight solution. Containers have their own file system, CPU, memory, process space, and are decoupled from the underlying infrastructure, making them portable across clouds and operating system distributions. Containers became popular due to benefits like agile application creation and deployment, continuous development and deployment, dev and ops separation of concerns, observability, environmental consistency, portability, application-centric management, and efficient resource utilization. So these are the benefits. Containers, similar to VM, share operating system, but they share operating system has its own file system, CPU, memory. They get decoupled from process space, and containers has underlying infrastructure which they depend on, portable across clouds and operating system distributions. It doesn't matter whether from Windows you go to Unix or some version of Red Hat Linux, CentOS, or you run on your local computer like Windows Server or a Mac. And containers got adopted due to their agile application creation and deployment, continuous development deployment, DevOps, observability, and environmental consistency, portability, application-centric management, efficient resource utilization. Now I will just illustrate, I'll just point out the differences between VMs and containers. So first is isolation. VMs provide strong isolation as each VM runs its own operating system. Containers share the host operating system but isolate the application process. Size. VMs are large in size as each VM carries a full operating system. Containers are lightweight as they share the host operating system. Startup time. VMs generally take longer to start up due to the need to boot up an entire operating system. Containers start up quickly as they run on the host OS. Performance. VMs have more overhead because of the duplication of an entire operating system. Containers have less overhead as they share the host OS. Resource allocation. VMs require a specific amount of resources to be dedicated to them at creation. Containers use only as much resource as an application needs at a given moment. Hardware level. VMs are hardware level process virtualization. Containers are an operating system level process virtualization. So this is hardware level process virtualization. This is OS level process virtualization. System calls. VMs can make direct system calls to the host OS. Container system calls need to go through a translation layer unless using something like gvisor for added security. Portability. VMs, due to their size and hardware abstraction are less portable. Containers are highly portable and can run anywhere the container runtime is installed. Security. VMs are considered more secure due to their isolation level. Containers, while secure, can potentially be less so due to the shared kernel. Understanding why we need Kubernetes. In production environment, we need to manage the containers running applications and ensure no downtime. If a container goes down, another container needs to start automatically. Kubernetes handles this behavior. So if you just run that container using Docker or Containerd, there is no guarantee that if a container has a downtime or has a failure, another one should automatically start up, and so there should not be any failover, or it should be like highly available. So this, if you just run it without container using Docker, it wouldn't be possible. Means it would be possible, but through some other container orchestration like Docker Swarm or something. But Kubernetes came into picture because it can handle this feature as well as a lot of other additional benefits. Kubernetes offers a resilient framework to run distributed systems. It manages scaling and failover for applications. It provides deployment patterns and more. For instance, Kubernetes can manage a canary deployment easily. So this is one of the example, like it provides canary deployment. It can provide another like blue, green, A/B testing, all those advanced features. Production environment manages containers running applications, and Kubernetes can handle this particular behavior, containers running applications. And if you just have containers, there's a potential for downtime, but Kubernetes prevents by starting another container. And Kubernetes provides a resilient framework to run distributed systems. It manages scaling and failover for application. It provides deployment patterns. For example, canary, it can be blue, green, it could be A/B testing, or it could be any other strategy to distribute the traffic or do some kind of testing. So what Kubernetes provides? Kubernetes can expose a container using DNS name or their own IP. If a container receives high traffic, Kubernetes can load balance and distribute the network traffic for a stable deployment. Kubernetes provides automatic mounting of your chosen storage system. It could be local storage, public cloud providers, etc. With Kubernetes, you can describe the desired state for your deployed containers. It can change the actual state to the desired state at a controlled rate. For example, Kubernetes can automate the creation of new containers, removal of existing containers, and adoption of all their resources to the new container. Automatic bin packing. So you provide Kubernetes with a cluster of nodes to run containerized tasks. You specify how much CPU and memory, for example RAM, each container needs. Kubernetes can then fit containers onto your nodes to make the best use of your resources. So automatic bin in the sense automatic binary packing. So same way we deploy some executable or something. So it actually packs everything and provides automatic resource, CPU and memory. Kubernetes has self-healing capabilities. It restarts containers that fail, replaces containers, kills containers that do not respond to your user-defined health check, and does not advertise them to clients until they are ready to serve traffic. Kubernetes lets you store and manage sensitive information such as passwords, OAuth tokens, and SSH keys. It allows you to deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. So these are the benefits: service discovery and load balancing, storage orchestration, automated rollouts and rollbacks, automatic bin packing, self-healing capabilities, secrets and configuration management. So now let's see what Kubernetes is not. Kubernetes is not a traditional all-inclusive platform as a service system. While it provides some features common to platform as a service offerings such as deployment, scaling and load balancing, it operates at the container level and not at the hardware level. These solutions are optional and pluggable. Kubernetes aims to support a diverse variety of workloads, including stateless, stateful, and data processing workloads. If an application can run in a container, it should run well on a Kubernetes. Kubernetes does not deploy source code or build your application. Continuous integration, delivery, and deployment workflows are influenced by organization, cultures, preferences, and technical requirements. Kubernetes does not provide application level services like middleware, data processing frameworks, databases, caches, or cluster storage system as built-in services. These components can run on or be accessed by Kubernetes applications via portable mechanisms like the Open Service Broker. Kubernetes does not prescribe logging, monitoring, or alerting solutions. It offers some integrations as proof of concept and mechanisms to collect and export metrics. Kubernetes does not provide or mandate a specific configuration language / system. It offers a declarative API that can be targeted by different forms of declarative specifications. Kubernetes does not provide or adopt any comprehensive machine configuration, maintenance, management, or self-healing system. Kubernetes is not just an orchestration system. It consists of independent, composable control processes that continually drive the current state towards the desired state, making it easier to use and more robust, resilient, extensible system and solution. So these are Kubernetes is operating at container level, supports diverse workloads. It does not deploy source code or build application. It does not provide application level services, does not dictate logging, monitoring, or alerting solution, does not provide or mandate configuration language or system, does not provide any comprehensive machine configuration, maintenance, management, or self-healing, and is just not an orchestration system. So I just have to fix this typo. This should be does not, or there should be nothing. So sorry for that. And that's all. Thanks for watching.